So good morning students. So this is Dr.S.Jothilakshmi, Assistant Professor of Computer Science, the Standard Fireworks Rajarathinam College for Women, Sivagasi. So in this lecture video, so you are going to study about stack representation, stack operation and stack applications. So first you are going to know about, so what is stack? So the data structures can be classified as two types. One is linear data structure and another one is non-linear data structure. In linear data structure, the data are arranged in a linear fashion. In non-linear data structure, the data are arranged in a non-linear fashion. So stack is a type of linear data structure. So stack allows the data in the form of last in first out or first in last out. It means we can insert and delete the element at the one point of the stack. So it is last in first out or first in last out. These are the various examples of stack. So in this picture, the coins, plates and books are arranged in a linear fashion. So it is arranged one by one. The top of the stack is pointed as a stack pointer. Next we are going to see about the representation of stack. Stack can be represented in two ways. So one is array and another one is linked list. We have to represent in a array representation so as a fixed size. In array representation, the items of stack can be stored in a sequential fashion. So this is linked list representation of stack. So in a linked list representation, the data part represents the assigned value of the stack and the pointer represents the next item of the stack in a linked list. Next we are going to see about the stack operations. There are two types of operations in a stack. One is push operation and another one is pop operation. So push operations means we have to insert an element in the stack. We have to insert element at the top of the stack. So pop operations means we have to remove the element from the stack. We have to remove the top of the element from the stack. So this is the procedure of push operation. First we have to check the stack. If the stack is full means we have to give as a message stack is full and error message. Then next we have to increment the top of the stack. We have to insert an element to the top of the stack. So this is the algorithm for push operation. First we have to check the stack size. If the stack size is full means we have to print stack overflow. Otherwise we have to increment the top of the stack as top equal to top plus 1. Next we have to assign the value to the top of the stack. So in this picture the stack size is 5. It's an empty stack. The top of the stack is equal to -1. Next we have to increment the top of the stack. So it is top equal to 0. Then we have to push the element 7. Then next we have to increment the top size. It is top 1. We have to push the element 8. Next we have to increment the top. So it is top 2, then we have to insert an element 9. Next we have to increment the top. So it is top 2, then we have to push the element 4. So finally we have to increment the top, then it is pointed as top 4, we have to push the element 5. Next one is the pop operation. So in pop operation, so first we have to check if the stack is empty or full. If the stack is empty means, if the stack is not empty, then we have to access the data element to the variable. Next we have to decrement the top pointer by 1. So this is the algorithm for pop operation. First we have to check the top value. If the top value equal to -1 means we have to print the flow. Then we have to, otherwise we have to remove the element from the top of the stack. We have to assign the element to a variable. Then next we have to decrement the top value by 1. So it is top equal to top -1. So in this case that stack is full. So we have to assign the element and at the top of the stack, it is 5. Then next we have to decrement the top of the stack. Then now the top of the stack is pointed as top 3. Then we have to remove the element 4. So at this manner the top of the stacks are assigned to a variable. So these are the various applications of stack. Stack can be used to evaluate of arithmetic expressions and backtracking. So backtracking is the another application of stack. So it's a recursive algorithm. So that is used for solving the optimization problem. Next we have to used for delimiter checking. So it is nothing but it's a parenthesis checking. Then next one is reverse data. So we have to use stack to reverse a given set of data. So these are the frequently asked questions in stack. First one is the explain stack, then discuss about stack representation. So illustrate push operations on stack with neat diagram and pop operations on with neat diagram, and describe the various stack applications. So thank you students for visiting this lecture video on stack.